We've spent some time up until now looking at straight line graphs. Sometimes those straight line graphs may have had more than one straight line graph, or more than one straight line. Might have looked something like this. Okay, but they're all straight lines. They all represented constant velocities. Okay, whether it's a constant velocity of a certain value, a constant negative velocity, or a constant velocity of 0. Stop. Okay, they're all constant velocities. We just had a quiz on those graphs. Okay, we know how to find the position at any given time, or the displacement, or the average velocity, or the instantaneous velocity, so on. What do we do when we get a curved graph, though, that looks like this? This is a position time graph where it's curving upwards. Tell me, first of all, what this represents. Forget about finding anything, okay, A, B, C, D, or E. Just tell me what it means. What's going on in this one? Ryan, look like you're ready to give me an answer there. No? No? What does this one mean? Yeah, it's accelerating. It's speeding up. Now, if it's speeding up, if it's accelerating, we can still find the position and displacement in exactly the same way as we have the straight line graphs. We can do A, B, and C already. Let's do it real quickly here. Position at 6 seconds would be, goes up and over, it would be 3 meters. Easy. At 0 seconds, it would be 0. At 8 seconds, it would be, let's go up and over, the position would be 5 meters. It's exactly the same as the straight line graphs, exactly the same as what you saw in your quiz here today. But, and so is D actually, the displacement between 0 and 8 seconds would simply be 5 meters minus 0 meters, which gives me 5 meters. But when we get to question E, the average velocity between 0 and 8 seconds, how do we deal with that? How do we deal with that one? The average velocity between 0 and 8 seconds. It's not a straight line. How do we find an average velocity when it's not a straight line? We have an equation, don't we, that describes average velocity? We learned it on the second day of class. V is equal to delta D over delta T. What does D stand for? Delta D, that is. Yeah, well, it's the displacement. What's the displacement between 0 and 8 seconds? We just found that, didn't we? It's 5 meters. What's the time between 0 and 8 seconds? Well, you better get this one. What's the time between 0 and 8 seconds? Good. Thank you, Jazzy. 8 seconds. 5 divided by 8 is going to give me 0.63 meters per second. We didn't have a straight line, yet we could still find the average velocity because we have an equation that describes average velocity, right? Make sense? What if I asked you to find the instantaneous velocity? Remember on those straight line graphs, the average velocity was the same as the instantaneous velocity at a moment in time? Here it's not. Here the velocity is changing with every moment in time. What if I said find the instantaneous velocity at 4 seconds? Here's what a lot of people want to do. A lot of people want to go, well, the position is 2 over the time of 4. The instantaneous velocity is 0.5 meters per second. But that would be wrong. So you shouldn't do that. We're going to draw what we call a tangent line on this one. Okay, we have to draw a line that goes through only that one point, only 4 seconds. Now that line is not going to look like this because it doesn't follow the curve. We want it to go through only that one point, but we also want it to follow the curve. So that line that I'm going to draw is going to be more like this. Oops. Hard to do this when you don't have a ruler, and it's hard to use a ruler on a smartboard. I'll see what I can do here, actually, if the ruler will work. It's going to look something like this. No, it's not going to work. Oh, no. That's brutal. I'll draw it by hand, and you're going to have to just kind of visualize what it would look like if it was a straight line. Does that make sense? It kind of skips over. It's kind of like, you know what I think of when I see this, to be honest? skipping rocks in the river. Okay, when you skip a rock in the river, okay, you kind of you bring your hand down and you throw the rock kind of following the path of the river, right? You kind of follow the path of the river, but it has to kind of just skip off of one point, right? The rock just kind of skips off of one point on the river. Here, my line is just kind of skipping off that one point at 4 seconds. Does that kind of make sense? Okay, here's what I'd like you to do right now. Before we do anything else with this, we haven't got the instantaneous velocity yet, but we're one step further to getting it. What I'd like you to do is to draw that line of best fit with a ruler for question number 4. It should look something like this. And I'll take a walk around as you're doing that, just to make sure that you're drawing a reasonable line of best fit. Yours might be slightly different than your neighbor's. Okay, and that's okay if it's not perfect, but we want it to be close. Okay, so when you've done it, just let me have a look at it. We'll see how good it is, and then we'll come back here and do our calculations with it, okay? Okay, everybody seems to be drawing a pretty good tangent line here. I was about to say line of best fit. That's not what it is. It's not a line of best fit. It's a tangent line, a line that skips by and hits only one point. Okay, we seem to be doing a pretty good job. We only want to touch that one point again. If we're using the water slash skipping rock analogy again, we want the rock to skip off one point in the water, not to go along the surface of the water and then skip off. It just touches one point on the water. All right, now what do we got to do? To find the instantaneous velocity at 4 seconds, let's take the slope of the line. Let's take the slope of our tangent line. So it's going to be y2 minus y1 over x2 minus x1 again. y2, doesn't matter where I make it. Okay, I can pick 2 points. Let's pick, actually that's a bad idea. Let's use a different color here, so I can distinguish where my points on my line are that I'm going to use to find the slope, and where the point is that I'm trying to find the instantaneous velocity. So I picked these 2 blue points here. y2 minus y1, I'm going to say 5 minus 0 over, and that's meters by the way, over x2 is going to be 10 seconds minus 1 second. So I get 5 over 9 is equal to 0.56 meters per second. I'd like you to find the slope of your line now. You should get something fairly close to 0.56. You probably won't get the exact same number. It's difficult with these tangent lines to get a perfect line. And having said that, who says mine's perfect, right? Okay, I do it by hand, by freehand. So my number may be off by a little bit as well. You get a slightly different number. Yours might be better than mine here. Should be somewhere in that range, though, of 0.56 meters per second. Okay, let's do that now. Okay, you guys seem to be doing really well at this. We'll move on here now. Okay, nothing to stop you from doing a couple practice tangent lines at home. Okay, just draw a curve. You don't even have to draw a graph. Okay, draw a curve. Okay, practice your tangent line. And make sure that you're okay with that. And if you have any questions about it over the weekend, just let me know. Today we're going to go forward a little bit from where we have been with constant velocity. Talk about acceleration. Acceleration is the rate of change of velocity. Similar to what velocity was the rate of change of position. Anything that's a rate, anything that has the word rate in it, is going to have time on the bottom. The rate of change of position was delta d over delta t. The rate of change of velocity is going to be delta v over delta t. So the main equation that describes acceleration, how quickly velocity changes, is this. A is equal to delta v over delta t. Remember, this does not describe how fast something's moving. That's velocity. You can have a really, really high acceleration and be moving really, really slowly, or a really, really slow acceleration, but be moving really, really fast. This is only how quickly the velocity is changing. Something that's moving really, really fast may not be changing its velocity at all. It may have an acceleration of 0. What are the units that we'd use? Well, if we look at velocity, it's meters per second. Time is seconds. So you could write meters per second like we have there, Or we could simplify that a little bit and write meters per second squared. That's typically the way we're going to write it, is meters per second squared. So a new definition, the rate of change of velocity, it's acceleration. A new equation, delta V over delta T. It describes the rate of change of velocity. But there are a number of other equations that also describe acceleration. For instance, d is equal to VIT plus 1/2 AT squared. That looks ugly. What does d stand for? Delta D stands for the displacement. VI stands for the initial velocity, how fast it's moving at the start of the problem. T stands for time. A stands for acceleration, of course. There's another one that looks a lot like that. D is equal to VFT minus 1/2 AT squared. All the same variables here. We got a negative instead of a positive. What does VF stand for? That's a little bit different. VF is, VI is the initial velocity. VF is the final velocity, right? Here's another one. VF squared is equal to VI squared plus 2AD. A stands for acceleration, D stands for displacement. VF stands for what? No. Oh, what's wrong with that, Liam? Final velocity? Everybody was thinking the same thing, weren't you? Every single person in this room was looking at this and saying, oh, that's final velocity, and then was shocked when I said, Liam, you're wrong. What is it? It's final speed. Yes, it's final speed. Okay, in the first two equations, you see those little vector signs over it? Initial velocity, final velocity. Here you don't. Final speed, initial speed. We're still going to use the standard units, meters per second squared, meters, seconds, and so on. Here's one more. D is equal to VIT plus, sorry, already gave you that one. How about D is equal to VI plus VF over 2 times T? This doesn't even have acceleration in it, but it still describes acceleration because VI and VF are two different numbers. So in this equation, the object is accelerating, the object is speeding up. We just don't know what the rate of acceleration is. We just have the initial and final velocity in that case. All of these equations that you see up on the board right now, we're going to name group B equations. The equation that we learned last week, E equals delta D over delta T, we're now going to call that group A. Whenever you have a constant or average velocity, we're going to use group A. Whenever the problem involves acceleration, we're going to use group B. So now the first thing that I want you to do when you see a word problem is take a step back from it for a second. Don't write down your givens right away. Look at the problem. Look at the big picture. What's going on in the problem? Is it accelerating or is it moving at a constant velocity? If it's moving at a constant velocity, you should go directly, constant or average velocity, go directly to that equation, my group A equation. If it's accelerating, if it's speeding up or slowing down, you should throw away that one that's in green there and go to the red ones. Go to my group B equations because you've got to use one of those 5 group B equations if it's speeding up or slowing down. Does that make some sense? So we've gone today from having one equation to all of a sudden having 6 equations all in one day. Okay, that's not a big deal. It just becomes more important now to write down our givens so that we can figure out which of the 6 we're going to use. Okay, we We look at group A or group B based on the big picture in the problem, and then we look at which one within that group by what we have written down for givens. Okay, does that make sense? We're going to do one problem here today. One new acceleration problem here today. And that's going to be the one that appears on page 47 of your textbook, 1.12. It says a hybrid car with an initial velocity of 10 meters per second accelerates at 3 meters per second squared. How long will it take the car to acquire a final velocity of 25 meters per second? Okay, first thing you're thinking here, guys, is it group A or is it group B? Is it traveling at a constant velocity, constant or average, or is it accelerating? What's the answer to that question? Constant or average or accelerating? Group A, group B. Quinn, is this accelerating or traveling at a constant velocity? Good. If it's accelerating, we're going to use group A or group B. Group A or group B? Group B. Good. So we go to our group B equations. Back here, there's 5 of them. We have to figure out which one of the 5 we're going to use. Now we're going to write down our givens to help us with that, okay? So let's go back to the question. Let's say that the initial velocity, VI, is 10 meters per second. We'll make that positive. We'll say east is positive, so it's just positive 10. The acceleration here, not V. When you see meters per second squared, it's not V, it's A, acceleration. It's 3.0 meters per second squared. My final velocity is 25, and I'm looking for T. Now, I want you to know this. Who told me this was a group B equation? I can't remember. We know this is going to be a group B problem. We know that we're going to have to use one of these 5 equations. If you have your givens written down correctly, and if you can rearrange equations and plug numbers in correctly, you will not make a mistake at this point. It doesn't matter which equation you pick. Okay, if I pick, let's say, this one, the first one, d is equal to VIT plus 1/2 AT squared, and I want to solve for T here, what's the worst that's going to happen? Okay, I don't know what D is. I don't know what, I do know what VI is. I do know what A is. I get too many unknowns. I don't know what T is. I don't know what D is. I can't solve it. That's the worst that's going to happen. If you identify that it's a group B equation and you pick the wrong group B equation, you're not going to get the question wrong. You're just not going to be able to get the question. So what do we do at this point? If I picked a group B equation and I knew that I was supposed to pick a group B equation, but this one didn't work, what should I do? Try another one. Okay, try another one that seems to fit the givens a little bit better than that one. Okay, it's no big deal. Okay, I pick the wrong equation sometimes. Okay, as long as it's in the right group, that's okay. Which one do you think is going to work here? We've got VI, VF, and A. We're looking for T. Which of those red equations seems to work the best? Anybody want to take a stab at that? Yeah. Okay. VF squared. VF squared is equal to VI squared plus 2A times D. That William? Okay, let's take a look at that. Do I have VF? Yes. I've got final velocity, but a final speed would just be 25 with no direction, right? VI would be 10. Okay, got it. A, I got it. I could solve for D here, right? But that's not what I'm looking for. Have I got the wrong answer? No, I just solved for something I wasn't looking for. That's okay. Okay, maybe, in fact, you can use delta D with another equation to find T. Anybody else want to try a different one, though, that maybe gets the answer right away without having to go through that 2-step process that we would have to there? And that with Liam? Remember, I've got VI, I've got VF, I've got A, I'm looking for T. Yeah? This one? This one? Okay, you're real close. That's the equation that I do want to try, but it's not average velocity that you want to find. It's change in velocity that you want to find, right? Delta V is change, not average. So let's try that one. Let's see if that one works for me, okay? Liam, if you try that one, that's fine. Get delta D. You can either try again, or you can use delta D to help you out as another given. I'm going to try this one, though. A is equal to delta V over delta T. I want to find T, so let's get it to the top. Multiply both sides by T. A times T, delta V over delta T, times T. I've got A times T is equal to delta V. But I want T by itself, so now we get rid of the A. Divide both sides by A. That cancels. I end up with T is equal to delta V over A. Delta V is VF minus VI. It's 25 minus 10. A is 3.0. That gives me 15 over 3, which gives me 5.0. Units would be what? Time. What are the units? .0 seconds. Does that make some sense? Do not panic if you're having trouble finding the right equation. You need to be in the right category of equations, group A or group B. If you're in the right group, okay, sooner or later it's got to work out for you. If one doesn't work, try again. If it doesn't work, try again. There's only 5. Okay, so the most that you're going to have to do is try 5 times, and you're going to get the right answer at that point. Is that good? Okay, here's your homework for the weekend. Not very much. I want you to do the practice problems on page 47. Practice problems, page 47, number 1 to 16. Is that okay? You know what? I'll tell you what. I feel really nice today. I feel really generous today, and I don't want to overload you with homework this weekend. So let's cut that down, page 47. Let's cut it down 1 to 2. How about that? Sound okay? Page 47, number 1 to 2. Have a good weekend, guys.